Good evening, everyone.
Good evening, ma'am.
Yeah.
Good evening.
Yeah, is my screen visible?
Yes, ma'am.
Okay. Yeah. So I will wait for 4 or 5 minutes for everyone to join. Then we'll start today's session. In today's session, we'll be seeing some problems from week 3 and also a few problems from circuit related questions. Okay.
Okay, ma'am.
Yeah, try solving this question and you can write the answer in the chat box.
I think it will be 1 volts.
Yes. So yeah, so if you see the question, it is given B of t is a sine wave whose equation is root 2 sine omega naught t plus 5 volts. We have to find the RMS value. What is the formula for RMS value?
Ma'am, peak value divided by root 2.
Yeah, it's peak value divided by root 2. So here the peak value is,
Root
Root
2.
2.
yeah, root 2. So it is 1 volts. So general equation is V of t is equal to Vp sine omega t plus 5. What is Vp? It's peak value, right? What is omega?
Angular velocity.
Yeah, it's angular frequency. What is phi?
Phase difference.
Yeah, it's the phase. Then what will be the peak to peak value here?
Ma'am, 2 root 2.
Yeah, it will be 2 Vp volts. So the since we have to find the RMS value is nothing but 1 volts. So yeah, anyone have any doubt in this question?
No, ma'am.
We'll move to the next question. A house has the following appliances. 2 bulbs of 40 watt with duty cycle 1 for with the duty cycle 1, and it is used for 4 hours per day. In the same way, 3 tube lights of 60 watt with a duty cycle 1 used for 6 hours per day. 5 fans, 80 watts, duty cycle 1 again, used for 10 hours per day. 1 AC with 1 kilowatts, 0.9 duty cycle, used for 6 hours per day. Then again 1 fridge, 0.25 kilowatts with a duty cycle 0.25, used for 24 hours per day. Find the total number of units consumed per day find the total number of units consumed per month, assuming 1 month has 30 days. If 1 unit is 8 rupees, then find the cost for 30 days. Yeah, you can try finding the answer for this, and you can write the answer in the chat box. I'll wait for around 4 to 5 minutes.
Actually, I have a doubt. What about duty cycle?
Duty cycle, yeah. So first I'll explain about duty cycle. So if there is an application like AC or fridge, mostly like for cooling agents, so cooling machines. So what this does is, first how this AC works, it will first remove the heat, right, to bring the cool condition. So that is one work of it. That is to remove heat and to maintain that cooling condition. Then the next one is, it doesn't allow the heat to enter. Like it will be acting as a no heat, no cooling loss. So to remove heat, it will be doing more work. Whereas to maintain it, it just have to be a closed one. So how this AC usually works is, if it is used for 2 hours, initially it will be maintained at high. Then once once the temperature which we want, if it is 25 degrees Celsius is reached, it will turn off. Its other job is to maintain that temperature. So again, if someone else opens the door, then there will be a heat loss. Then again, it will become high to maintain the temperature. Then again, it will be turning off. So this AC, it has some certain watts, right? As given in this question, it has 1 kilowatts. This 1 kilowatts will not be used throughout the time. This 1 kilowatts will be used only when it is high. When it is low, it will be switched off. Again, when someone opens the door, it will be turning on high. So some of the applications has this type of criteria. So there comes the duty cycle. Duty cycle is nothing but the time it is on by total time. Total time is nothing but the time it is on and off together. So duty cycle is usually given in some ratio, right? So if you see here, AC is 0.9. That means if I take this as 1 hour, for 0.9 hours it is on. Then to the remaining time it is off. So that's why. So the duty cycle of that one, it means like uh, for like if it is a ratio, right? As it is given here. Are you able to understand now what is duty cycle?
Ma'am, 0.9 itself is the ratio of the duty
Duty
cycle.
cycle. Yes.
We need not substitute individually for
No, no,
time for on
no,
and
no,
off.
no. Here, if you see the question, it is directly given. Its duty cycle itself is 1.
Duty cycle is itself a ratio.
Yes.
Okay. I got it.
Did you discuss the theory of week 3? Yeah, the class which happened on Wednesday. So that will be there. We'll be talking about the week 3 theory. You can refer the live session link. That is the recorded video that has been released in the YouTube. Then week 2 graded assignment questions. Um, was week 2 graded assignment questions discussed?
No, ma'am.
Okay, yeah, maybe in the next TA session you will be having that.
Ma'am, next week.
Yes.
Ma'am, I think the total number of units per day. So it should be 9.38 or 9.4.
Okay. Yeah, please put the answer in the chat box now so that everyone can
Oh,
we
okay.
can compare and see whether.
Okay. Okay.
Ma'am, this is practice assignment problems.
The question which I wrote in the question, like in the paper, that one. No,
Yes. No.
no, no.
Okay.
The same pattern but different values.
Okay.
Shrish Mehrotra, can you please do the calculation again?
Ma'am, are these not correct?
Yeah, I
Okay.
think maybe you would have missed one value. I think. Yeah, please
Okay,
check it
ma'am.
once, no?
Okay, ma'am.
Yeah, others, please try and put your answers in the chat box. Okay. So yeah, if I want to find the power consumed by one, like yeah, how to solve this? Where to start it?
First, we have to find the energy.
First, we'll find the total power. So to find out the power consumed by the bulb. So for one bulb, it is 40 watts.
Then we have to multiply it with 2 and then
Yes.
the number of duty cycle.
Yeah, with the duty cycle.
In hours.
Here I am
Oh,
going to total power per day, right? So
Yes, sir.
I will also multiply with the hours it has been used per day.
Yes, sir.
Why we multiply with the 2?
2, because there are two number of bulbs, right? For one bulb,
Yes.
it is
Oh,
40 watts.
2 bulbs for 1 day, 4 hours.
Yes.
Okay.
So what will you get?
320 kilowatts.
Yeah,
8
it's
into 1.
320 watt hour
Yes,
per day.
320. Yes.
So the same way, next one. So it consumes 60 watts into 3 tube lights. Duty cycle is 1, again 6 hours per day. So tell me the answer one by one.
1080 watt hour.
Yeah, it's 1080 watt hour per day. And then next one.
4000 watt hour.
Yeah. This one is 1K.
5.4.
5.4K, right?
Yes.
This is 1K. So what about this last one?
It's 50.
0.625
What is it?
into 20.
0.25K into 0.25 into 24.
It's 1500.
Yes, per day. So if I add it, I will get the total power that has been consumed per day, right?
Then the last two should be in kilowatt because it is given power is given kilowatt. So it should
Yeah.
be
So
kilowatt hour.
what I did is I did 1000 into zero point 0.9 into 6. I
Okay, okay,
converted
okay,
kilowatts
okay,
into
okay,
watts.
okay.
So this will be 320 plus 1080.
12,300.
Yes. So it will be
To
12,300.
convert watt hour into kilowatt, we had to
Hour.
multiply into 0.9 into 6.
No, divide
So,
by
but in the yeah, you have to divide it by 1,000.
yes, ma'am. Ma'am, 12.3 is the right answer, I think.
Yeah. Why are we dividing it by 1,000?
To find in a
Because
kilowatt.
yes, because 1 unit is equal to 1 kilowatt hour.
Yes, ma'am.
So my
Like
total
why
power
we
per day is
12.3 units.
yes. So the total power per day is 12.3 units. So this is my answer for A. What about B?
And 30 to 12.3.
Yes. Total power per month. So whatever I calculated for day into 30 days. 12.3 kilowatt hour per day into 30 days. So it will be, what is the answer?
169.
Is it 169? 12.3 into 30, right?
No, 369.
Yeah, 369 kilowatt hour. So here also, since you are finding it in units, 369 units. Then C. So 1 unit is 8 rupees. 369 unit is
Multiply by 8.
yes. So you will be getting around 2,950 rupees. Yeah, did you guys get the same answer? Did anyone have any doubt in this question?
No.
Ma'am, power is equal to energy. Can we say power as energy?
You want to say power as energy? Yeah, yeah, yeah.
How to convert the joule to a joule in a
No, can you please repeat?
yeah.
What were you
How
asking?
can we convert that unit 1 unit into joule? Can we convert?
Okay, you want to convert?
Yeah.
Okay, yeah, okay, okay, yeah. See, what is joule? Joule is watt into second, right? It's
Yes.
energy. So if you want to convert watt hour, kilowatt hour into watt second, what should you do is you have to convert kilowatt into watt. That is 1,000 into
Seconds.
watts. Yeah, however
Huh?
you have to convert into second. That is 60 second. So this will be
Yes.
60K. That 60,000 you have to multiply with that so that it will be converted into joules, right?
Yes.
No.
Yes.
I
Is
think I
someone
saw
talking?
that question in which we had to
Ma'am, 60
find
into
in
60.
joules.
Okay, yeah. Is it clear? So
Yes,
kilowatt
ma'am.
hour, you are just converting into watt second. Watt second is joule.
Ma'am, 60 into
Okay.
60.
Yeah. 60 into 60.
Yes, ma'am. To
Yes, yes,
convert
because it,
also.
yeah, yes. Yes, sorry, yeah.
Into 60.
Yeah. Because 1 hour is equal to 60 minutes, then 1 minute is equal to 60 seconds.
60
Yeah.
seconds. So again we
So you
had to
complete.
multiply with 60.
Yes.
Okay.
I hope this is right.
Yes, ma'am.
Joules. Right? Shall we move to the next question?
Yes.
Do anyone have any doubts in this?
No, ma'am.
Okay.
Ma'am, could you please tell me the peak voltage and what is the difference between peak voltage and voltage?
Yeah, for this, the question which I am going to explain now, it will show me the clear difference between all those.
Okay.
So this is a graph that shows the current passing through the resistor. So this is a sine waveform. So this point is 2 second, this point is 4 second, this point is 6 second, this point is 8 second, and this value is 12 amperes. So you have to find peak current, peak to peak current, time period, frequency in hertz, frequency in radian per second, RMS current, then find the current equation. If the current you have to find the current at time t is equal to 1 second or maybe 0.5 second, because finding it at 1 second is easier. Okay, yeah. Yeah, try solving this and write the answer in the chat box. Maybe for around 4 to 5 minutes I'll wait. Yeah. So everyone try and write the answer in the chat box, and then we will compare the answers and see. And if you guys have any doubt in any of the questions, you can ask. So one clarification. It's basically if calculating the energy, right? It's not actually finding the power. Total number of units is actually energy. Yeah. Time period is 4 seconds, yes, right. And frequency is 0.25 hertz. That's also right. Yeah. And the answer for peak current is 12 ampere and peak to peak current is 24 ampere. Yes, right. So if this is a sine wave, what is this? What is this direct with what is this distance called?
Peak current.
Yes, this is called the peak value. From the positive peak to the negative. What is this value?
Ma'am, peak to peak.
It's peak to peak value. Then, so if you take a sine wave, after this one full cycle, it repeats itself. So this is called
Time period.
time period. What is frequency?
1 upon time period.
Yeah, it's 1 upon time period. It basically says the number of cycles in 1 second, right?
Yes, sir.
Then what about omega?
It's
Omega is
2 pi frequency, 2 pi f.
yeah 2 pi f or 2 pi by t is the angular frequency or yeah. Then as you already saw in the first question, RMS value is nothing but peak value by root 2. Then what is the equation of a sine wave? If this peak value is a, the equation of a sine wave will be a sine
A sine omega t plus phi.
yes. Here a is nothing but is it a peak value or peak to peak value?
Peak.
Only peak value.
Yeah, peak value. Omega is angular frequency. Phi is phase. What is the phase
Sir?
here?
Is ma'am how to calculate this phase? This.
Yeah. So I will take 3 sine waves. So this is a sine wave here.
Then this phi is basically phase difference, no?
It's a phase. If you are taking 2 waves, then it becomes a phase difference.
Okay.
5.
Phi is phase.
But
Okay.
if we are given
So sometimes, yeah, if you are taking 2 waves that are coming like this, if you are going to, so this wave will have one phase and this wave will have another phase. If you are going to find the phase difference between the two, then we will call it as phase difference. Phi 1 minus phi 2. Okay.
5 2. Yes.
but here we have only one wave.
Yeah, so it is only phase.
Can we
So
say
to
more?
find the phase, what I will do is I will substitute t as 0.
Yeah.
If you see at this point for this wave, at time t is equal to 0, what is y of t?
Is sine 0.
Yeah, it's not sine 0. If you see at time
It
t,
will
y
be
of
A
t,
sine phi.
yeah, a sine phi.
yes, a sine 0t plus phi. A, if I take this as some phi, let it be phi, okay? So I will substitute 0 is equal to phi. So this is how I will calculate phi. So phi is equal to 0 here. Okay? For this way, phi is 0. So if I take it for here, y of 0 is equal to a sine 0t plus phi. What is at time t is equal to 0? What is the value of y of t in the second graph? It's
Ma'am,
phi, right?
5.
Yeah, it's phi. So again, a is equal to phi. So sine phi is equal to 1. What is phi?
90 pi by 2.
Yes.
So basically, the value of phase is found by this substitution
0
method.
intersect. Yes.
Okay.
Whereas here the phase will be minus pi by 2, right?
Yes.
So what does it say? At 0, the phase is pi by 2. It is 90. So it is. So if okay, since if I will take this as reference. Okay. Is the second wave leading or lagging?
Leading.
Yeah, this is leading with respect to reference. Whereas the third wave is
Lagging.
with respect to reference.
Ma'am, how did you say that lagging and
minus by d.
See the y of t is 0 here.
yes,
Only at this point y of t is 0. So it is going
yes.
before this. So it is leading. Whereas here y of t is 0 at this point.
Okay, so
It is leading from here.
Okay,
Yeah, this is lagging, so that is leading. Okay.
and when it starts from 0, then
That is in phase, something like that. So it is with reference, it is in phase. Both the phases are equal.
Ma'am, could you please move the screen a little bit up? Just
This one, right?
ah. Okay, thank you.
And how the value of RMS is equal to peak value divided by root 2?
So there will be a derivation we would have seen in week 3, right? In the lecture. We would be so there is this lecture L point 3.4 under sinusoids. So there will be one derivation where we'll be deriving the p average value. From the p average value, we would get Vp square by 2r. So this is for an AC circuit. So in DC circuit, if you see, P value is equal to V square by R. So the DC equivalent for an AC circuit is Vp by root 2. So that we'll call it as VRMS. Actually, this has been explained in the lecture also. In week 3 summary session also, I would have explained this. So you can go through that once. If you have any doubt, you can ask me again. Is it fine?
Yes,
Ma'am,
ma'am.
could you please explain, repeat the last one?
Yeah.
Power, DC,
Which one? The face?
last one. The top
Last
right
one?
corner. Top right corner.
Top.
Power for DC circuit.
Okay.
Power
That,
for AC.
okay, 1 second. So in the lecture, we will be deriving the equation for, so there will be one circuit, which is like this. So V of t is the voltage, AC voltage. I of t is the AC current that is flowing through the resistor. Okay. For this, we would have found instantaneous power first. What is instantaneous power?
small
V of t
amount
by
of
of t.
Particular time.
Yeah, the power at one point of time. It's not a small amount of time. Okay.
okay,
So here they would have said V of t as Vp sine omega t. As if they would have taken this AC voltage as a sine wave. Okay. Then they would have derived this equation. Why did they derive P of t? Because we want to find E. E is nothing but P of t dt over one cycle. Then we would have derived to this one Vp square by R into T by 2. I would have got of Vp square T by R. Then what is P average? That is nothing but energy by time, right? So T and T will get cancelled. Vp square by 2R. So the average power for a AC circuit is Vp square by 2R. Okay?
Okay.
This is for an AC circuit.
Yes.
But if you consider a DC circuit, this is a DC supply with voltage V. The current flowing is I and this is R. What is the power formula? It's either VI
is equals to IV
V square by R
square R.
I square R. I will take I will take the second one P. In DC, instantaneous power is equal to average power, right? Do you agree with this? Okay, first let me tell you what is instantaneous power.
Ma'am, where VP is a peak voltage.
Vp is a peak voltage, yes. P of T is instantaneous power. Instantaneous power is nothing but power at a single point of time.
Yes.
If I say at 5 seconds, it is 10 watts. P of T, it will have some equation. P of T at 5 seconds is 10 watts. So at each point of time, the instantaneous power is will change in a AC signal. Whereas in DC, it is same throughout the signal. So P of T will be equal to P average, right? In DC. Do you agree?
Yes.
Yeah. So for DC, I have one power. For AC, I have another one power. Now I am going to equate this both. If I equate, what I will get? V is equal to Vp by root 2, right? This way I will take it as VRMS. So VRMS is nothing but, what will I call as, what is VRMS?
Root mean square.
VP
Okay.
by root 2.
Root 2. It is like if I want to find a certain some equivalent DC amount for a AC circuit. DC equivalent of an AC circuit. Okay, that we call it as root mean square or VRMS value.
Okay.
Ma'am, could you please explain little bit more?
You want me to explain it a little bit more?
The last one, VRMS.
Okay. See, by the DC, I got P is equal to V square by R. This is
Yeah.
DC power, DC voltage.
Yes.
Whereas VP is a peak voltage of a AC signal, right?
Yes.
I am equating this and this. What I'm trying to say is, if you measure a AC signal using a voltmeter, what will it give?
Pardon?
If you are measuring a AC voltage with a voltmeter, see, AC voltage is constantly changing on and off, right? It is going
Yes.
up,
Yes, ma'am.
going down.
Yes.
Yeah. But if you measure
Alternate.
using some voltmeter, we don't actually measure. If you see, like, see, if I am having a device to measure this voltage, then the AC voltage will
measure
be changing
instantaneous voltage.
fast. So what I will be finding is the average voltage or something. That I call it as root mean square.
Root mean square.
That is
Like, ma'am, light
DC
bulbs.
equivalent.
Light bulb. So when we see on a camera, then it on and off, but we can't see with our eyes. But when we on in the camera, we can see that lights is getting on and off any LED bulb or what.
Is it? So basically, like it's a DC equivalent for an AC circuit. That I call it as RMS value. So if in power supply and all, if you see 230 volts, it's actually is not the peak value of a AC signal. It's actually RMS value.
Multiplied it by root 2, then it will a peak voltage.
Peak value, yes.
What is the long form? You say RMS?
Root mean square.
Okay. Thank you.
So it's basically average, right? What is root? See, at each
Average
point,
of the
you will
voltage.
get- Yes.
Ma'am, what is the purpose of
Like, ma'am, when we see any graph up and down, but we will consider only the average value when it's
Yes.
in
It's
it
like an
is
average
constant.
value.
Yes.
I'm getting root mean by the total.
Square.
Then I am taking square. So that's why we call that as root mean square value, RMS value.
Okay.
What is the purpose of finding VRMS?
That's what I said, no? If it is a AC signal, if I want to measure it, it will be changing constantly. I will not be able to see the change happening. I will not be able to get a one value. So that I'm getting an average value. That average value is root mean square value,
Okay.
right?
I got it.
I hope it is clear.
Ah,
Or is it
Yes, ma'am.
confusing? Okay.
No, ma'am, it is like a speed. When we accelerated our bike or anything, we only consider the average the
Yes.
speed.
Yes, yes. Okay. Now we will go to our question. Now what is the peak current?
12 ampere.
12 amps.
Yeah, 12 ampere. Peak to peak current?
12 plus
So
24
this will
amp.
be
24.
minus 12. Yeah.
12 to
2
minus
VP.
12. 2 VP.
Time period? It is the time taken to complete one full cycle.
4 seconds.
2 seconds. For 1 second.
Frequency?
Yeah.
0.25 hertz.
Yes. This one?
1.57.
Pi by 2 radian per second.
Yes.
RMS current?
Like 12 by root 2.
6 root 2.
Yeah, 6 root 2.
Yeah, I'll take it as 8.49 ampere. Yes. Now tell me the current equation.
Like
What is the phase?
0.
0.
Yeah, 0.
So it
So
will
my
be
current
12
equation will be?
sine 1.57 t.
Yeah, pi by
Omega
2.
by 2 t. Pi by 2.
So the next question is at time t is equal to 0.5 seconds. So I have to, in the current equation,
T is equal to 0.5.
Ma'am, 12 by root 2.
what is the answer? Give me numerical value.
12 by root 2. Because it will be sine pi by 4. So it will be 1 by root 2.
Yes. Yes, right. 12 by root 2. It will be around 8.49 ampere. Right? So at 0.5 seconds, my amplitude will be 8.49 amperes. Right? Yes.
Yes.
Clear, right?
Yes, ma'am.
Yes.
Shall we move to the next question?
Yes. ma'am.
Yes, ma'am.
Yes.
Yeah. So this is the fourth question. Power supplied by a battery is a constant 6 watts over the first 5 minutes, 0 for the following 2 minutes, then the value increases linearly from 0 to 10 watts during the next 10 minutes. Then the power decreases linearly from 10 to 0 watts in the following 7 minutes. Find the energy consumed in the 24 minutes. Also find the average power. Yeah. So this one has 2 parts. Try it for around 2 to 3 minutes, then I will explain it.
Ma'am, when I see that too much big question, then I'm totally confused what to consider not.
See, first thing is, whenever you see a big question, you shouldn't panic, okay?
Yes. Okay.
See, this question is actually a simple one. First, you have to understand it. So, see, there is a battery, okay?
Yes.
It is supplying, it might have some voltage, some current, so it's having some power, okay? Some power has been supplied by this battery. And what it is telling, for the first 5
6
minutes, time has been given, power has been given. So, I'll go in order. For 5 minutes, it is 6 watts, okay?
Yes.
For this and this I have written. Then what did they give? 0 for the following 2 minutes. Next to 2
उसके बाद में
minutes,
वो after that
0.
yeah for 2 minutes it is 0. Yes.
Yes. Then read and tell me what is the next line.
A value increases linearly from 0 to 10 watts. That
Yes.
means power increases from 0 to 10 watts
Yeah.
linearly.
Linearly, like this, it is increasing, right? 0 to 10
Yes.
watts.
Then during the next 10 minutes, the power decreases linearly from 10 to 0 watts. Then it happens
Yes.
reverse of it.
Yes. In the next
It
7
decreases from
minutes, again from 10 to 0, right? Now, with this table I have created, I will draw the graph.
I mean 10 minutes and not 7 minutes.
Yeah. Then the power decreases linearly from 10 to
Linearly.
0 watts in the following 7 minutes, right?
7 minutes, yes.
So,
Yes.
time is given. In the y-axis, I will write the power. So,
Yes.
I will mark for the first 5 minutes. Next 2 minutes means 5 plus 2, 7 minutes. Then
Yes.
next 10.
10 minutes.
Not 10, right? 7 plus 10. So, 17.
10. Yes.
Then 17 plus 7.
24.
24. So,
24.
my x-axis is in minutes, time. P of t is in watts. Okay. So, what did they give?
Okay.
For the first 5 minutes, it is 6. This value is 6. Then for the next
Yes.
2 minutes, it's 0.
0.
Right?
And then from 0
It
to
increases
10.
10. Then from 10 to 0.
0.
Yeah. Now I got the graph P of t.
Yes.
So the theory, first I converted into table, then I converted into a graph.
Graph. Yes.
From the graph, now I think it will be easier, right?
Yes, ma'am.
Yeah. Now trying to find the energy, no? What is the energy formula?
Is it enough to find out the area?
Yes. Energy is nothing but P dt.
P dt. Yes.
Since it's a single integral, it is nothing but the area under the curve.
Correct.
So what I have to find? I have to find this area. It has
Circle.
2
Yes.
rectangle. I have to find this area. Then I have to find this area.
Yes.
What is the area of this one? It's a rectangle, right?
L into
Angle. Yes. length into
length
breadth.
into width. Yes. So 5 into 6. Then plus. This is one right angle triangle, right?
Half BH.
Yes, ma'am.
Yes. Of
14.
BH. Then,
Pythagoras theorem.
yeah. Now you can try it by yourself. Yes.
80.
Ma'am,
Yeah.
so area will be 115.
Half means.
Of yeah. Give the answer in joules. No. Convert the minutes into seconds. Give the answer in joules.
Okay, ma'am. Okay.
Yeah.
Ma'am, 6,900 joules.
Wait, I'll check and let you know. Yes. Yes, the answer is right. 115 watt minutes, then 6,900 kilojoule. Yeah, 6,900 joule, which is nothing but 6.9 kilojoule. Yeah.
I went for average power. For
Yes.
average power, I think so. We have to divide this energy by the total time.
Yes.
So, ma'am, it will be average power will be 4.8
Yes, it's
around about.
4.8.
Yes, ma'am. Ma'am, like precisely it is 4.79. So in exam we have to give 4.8 or 4.79 after round off, na?
Yeah, excuse me, please give me a minute. No, I will come in 1 minute.
Okay.
Yeah, thank you.
I think somebody's mic is open.
Yeah, yeah. What happened? Can you please repeat?
No, ma'am, I was just saying that somebody's mic is open. No, it is closed.
Okay. Okay. So yeah, the answer will be 115 watt minute.
6,900 joule.
One second. 6.9 kilojoule. Yes. And the average power will be E by T. 6.9K divided. Okay. Maybe instead of using 6.9K, I will use 115 watt minute divided by 24 minutes. Right?
Yes.
115 divided by 24 is equal to 4.79 watts. Yeah. Did
To
anyone have
find
any doubt?
average power, we had to find do But
You have
in
to divide the
when
energy by the time.
by time. Yes.
Yes.
Ma'am,
Thank
can
you,
we
ma'am.
have
When I see that is so much big question, then I get panic and don't even try to solve it. So many times I
ma'am,
Yeah. Yes.
uh, can we have these notes as a PDF in the portal?
Yeah. Yeah. So this one, are you in the Google Space?
No, ma'am, I am under qualifier
Okay.
level.
Okay. Okay. Then this, yeah. Anyway, this will be uploaded in the portal. You can see that.
In the study portal.
Yes. So yeah. So in exam, once you see big questions, it's like normal to get panicked, but it's okay. Whatever questions you have in your question paper, you know that
yes.
it will be under this week
And
1
we
to 4
had to
only. So
convert in a diagram or a simple thing.
yeah.
Yeah.
Yes.
Actually,
Yes.
when
Thank you, ma'am.
I looked at the question, really I couldn't find the central idea of the question. But
Mm.
after the table and the diagram, it will be more easy for me.
Yes.
Thank you.
Mention quiz one. The main syllabus will be from week two, or
It's not like that. You can expect question from all, but the main concept of this course is to make you more familiar with more circuits. So circuits is the main one, but you can expect questions from all weeks.
okay, ma'am.
Is a week 4 contents released? Yeah, right. Yeah,
Yes,
it's
ma'am.
been released.
It is released in today.
Yes. So yeah, week 1 will be very basic. Week 2 will be fully circuits. Week 2 is actually important. Week 3 you will be learning more about this waves, and it is also basic only. Basics related to waves and all. Week 4 you will be solving more and more problems. The full week 4 is dedicated to problem solving only. The lectures also.
Okay, ma'am. Ma'am, basically, week four is problem solving or circuits problem.
Yeah, circuit problems.
Okay, ma'am. Ma'am, so, as I have some doubts in week two graded assignments, so it will be discussed next week.
Yes.
Okay.
And if you see the portal, the answers will also be uploaded. Graded assignment solutions will be uploaded.
Ma'am, in IIT
Yes.
website or GSpace?
Not in the G space, in the
The
portal. Under the
portal.
supplementary contents, yes. You can see under the
Okay,
graded
ma'am.
assignments,
Hmm.
week 1 has been uploaded. No, in the similar way, week 2 will be uploaded soon.
Okay, ma'am.
Yeah. You can ask your doubts in the next TA session also, or you can go through the document also. It has not been, for week 2, it has not been uploaded yet, but it will be uploaded soon.
Ma'am, where can I get this as a PDF in the portal?
This slides, right?
Ah,
Yeah, if you see, under the same supplementary contents, there is one column called live session slides, right?
ah,
So there is a line. Click here for the link.
okay,
Click
okay.
that line. You will see many slides.
It comes under the slides, live slides.
Yes, live session slides under
Okay,
supplementary content.
okay.
Yeah, shall we solve more problems?
Yes, ma'am.
Yes, ma'am.
Okay. So this problems is some related to circuits. So there is one capacitor C1 and this is C2 connected with a DC supply. V is equal to 12 volts. So this is, let it be V1, let this be V2. You have to find QT. QT is nothing but the total charge in the circuit. This is A. find V1. C, find V2. D, find the charge stored in C1. Find the charge stored in C2.
So what is the value of C1 and C2?
Oh yeah, sorry. I forgot. C1 is 2 microfarad. C1 is 2 microfarad and C2 is 3 microfarad. What is the formula that we can use here?
One by C1 plus 1 by C2.
Yeah, that is to find the equivalent capacitance. C equivalent is equal to C1 C2 by C1 plus C2, which is nothing but 1 by C1 plus 1 by C2 the whole inverse. First you will find C equivalent. Then I have to find charge, right?
So we will use Q equals CV.
Yeah, Q is equal to CV. Here C is nothing but C equivalent, V is nothing but the total voltage. You can get the Q total. What is the C equivalent?
Remember, it will be 6 upon 5.
6 by 12.
QT is equal to 14.4 coulomb.
Yes, it's 14.4. Is it only coulomb or microcoulomb?
Microcoulomb.
Microcoulomb.
Yes, microcoulomb. Be careful with the unit. What is C equivalent?
Six by 5.
Yeah, it is something around 1.2 microfarad. Now, to find V1. How to find V1?
Again, Q equals CV in context of Q equals C1V. V1 will be
Q divided by-
7.2.
Yes. Total Q we have found out 14.4 microcoulomb divided by C1 is 2 microfarad. So V1 is equal to 7.2 volts.
When V2 will be 4.8.
Yeah, same way, 4.8 volts. What is the charge showed in C1?
Then 14.4, I think so.
Yes,
Because in series, the charge remains same.
yes. In series, charge remains the same.
Ma'am, in a capacitor,
Yes, in capacitor.
in like a resistors we connected in a series, then the current is same across the both resistors. And what happened with that capacitors? If we connected in a series, then current is divide or same.
See, if two resistors are connected in series, the current will be same, right?
Yes, but voltage difference.
Yeah, voltage will be different. It will be V1. This will be different. Same with in yeah, okay. In capacitor, I'm telling charge is conserved. So total charge is same, right?
Okay.
Voltage is different. What
Yes.
is charge with respect to time? dq by dt. So I1 will be dq1 by dt. I2 will be equal to dq2 by dt.
DT.
Q1 and Q2 are same. So I1 and I2 will be same, right? So I is also same.
Okay.
In series, the current
Because
will be same. That is the general concept.
yes, because the capacitors are inversely for like ma'am. We if you had to find equivalent capacitors of series, then we had to just opposite the formula of the find of resistance.
Yes.
Yeah.
Yes. Oh, that's why you got confused.
Yes.
You can try finding KCL at this point.
Okay.
What does KCL say? The current entering the circuit will be equal to the current leaving the circuit, no?
Current leaving the circuit. Yes.
Yeah. This is the I entering the capacitor and leaving this one. So this is the I. Since there is only one brush,
Entering
so
and
this will
leaving.
be equal to this current. Yes.
Yes, ma'am.
In all circuit, this KCL, KVL, and Ohm's law will be followed.
Ma'am, I did not use the KVL so much that why I did not have a practice with the KVL KCL. I just used that one superposition, and when there are so many batteries or resistors, then I am unable to solve that. What to do
Okay.
with?
So you're using superposition. You are aware of
Yeah,
superposition principle. Okay.
yeah.
Nice.
I'm
Anyway,
mostly using.
you will be learning superposition here also in around week 5 or week 6. Week 5, I think you will be learning superposition theorem. But
Yes,
you have to learn KCL and KVL also.
yes, ma'am. Because there are, if there are so many circuit in circuit, there are 2 or 3 batteries and resistors circuit,
Mm.
then unable to solve with that superposition method during the
Okay.
meshes or
Do you want me to discuss one problem with mesh analysis?
KVL. Yeah, KVL, KCL, ma'am. Did not
Yes.
clear with that topic.
So that is on 10 volt connected with a 10 ohm resistor, 5 ohm resistor, 5 volt, 5 ohm, so this is my circuit. So for beginning, I will go with a simple circuit. Okay.
Yes.
I want you guys to use mesh analysis. What is mesh analysis? Using KVL and Ohm's law.
Okay.
So the first step. So once you go for mesh analysis, the first step is you have to find the number of loops. Find the
Yeah.
loops and mark loop currents. So here there are
Like
two
there are
loops.
2 loops. Yes.
Yeah, I1,
I2.
I2. Then what does KVL say?
Current, sum of current entering the circuit
That is
equals to
KCL.
sum of current. We had KVL. Okay.
And sum of all potential is equal to 0.
Yeah.
Potential difference equal to 0.
Yeah, you can say like that also, or you can also say potential increase is equal to potential decrease.
Yes.
Yes, ma'am.
You can either say sum of all voltage equal to 0 or voltage rise equal to voltage drop. Right?
Drop.
Yes.
Yes, ma'am.
So what I will do is I will put voltage increase and all to one side, voltage drop and all to the other side of my equation. Loop 1. Okay.
Yes.
So 10. So if there is a voltage source and the current is going out,
So drop.
I will take that as positive. And if there is
Yes.
a voltage and the current is entering, now I will take it as negative.
Negative.
Here, yes, here it is coming out of the plus side, right? So I will take
Yes,
it as plus 10 volt.
Positive.
Is equal to, yes, all this resistance, there will be a potential drop, right?
Yes. Minus 10.
Yes. Voltage across the 10 plus voltage across the 5. 5 ohm.
5.
Yes. Then by Ohm's law, V is equal to IR, right?
Yes. And ma'am, we did not consider that 5 volt and that 5 ohm.
Yeah, I consider, see, this loop is associated with this 10 ohm and this 5 ohm only. It has no relation with this one. This is the next branch, right? This I1 is flowing only
Okay.
in this loop. So I will consider only the components which are in that pathway.
Okay.
Okay?
Yes.
So V10. So this is the 10 ohm. V is equal to IR. Resistance value is 10 into the current flowing the 10 ohm is I1. Right? 10 I1
Yes.
plus V5 ohm. The resistance is 5. What about the current flowing through this 5 ohm? In the 5 ohm, I1 is flowing in this direction and I2 is flowing in this direction. Right?
I1 minus I2.
Yes. I1 minus I2. Is it clear how you are writing this equation?
Yes, ma'am.
So 10 is equal to 15 I1 minus 5 I2. So this is my equation number 1.
Fine. Yes.
Now, you guys tell me the equation for loop 2.
Leaving from positive, then 5
Yes, it's plus 5
equals
volts,
to
right?
minus 5.
Why do you say minus 5?
Um, because of 5 ohm resistance there, it will consume the power. So it is then minus.
The voltage will be dropped only, right? So equal to in the this side, potential decrease 5 I2 plus 5 I2 minus I1,
I2.
right? So my equation will become 5 is equal to minus 5 I1 plus 10 I2.
Second
Is
equation.
it clear? Yes.
Yes.
Are you also getting the same equation?
Yes, ma'am.
So what is I1 and I2? Solve and tell me. You can use, there are two methods, right? One is elimination method, another one is, yeah, I forgot the name of that. But you can try elimination method, that will be easier for this. Note down the equation. I haven't told you the question yet.
I2 is 5.
You have to find the Vx and Vy, the voltage across both the 5 ohm resistor. That is the question. You have to find I1 and I2 for that first.
No, I2 is 5.
No, it's not 5. It is all this two equation 15 I1 minus 5 I2 is equal to 10 minus 5 I1 plus 10 I2 is equal to 5.
I2 is 1.
Yes. This is 1 ampere. This is 1 ampere. Now I want to find Vx. What is Vx? Vx is nothing but the voltage through the 5 ohm.
Ma'am, can you tell me just once that how did we get that one? Because ma'am, I did not solve the equations from so many days that.
Okay. See, there are two equations 15 I1 minus 5 I2 equal to 10. This I each one I can divide it by 5, right? 3 I1
Yeah.
minus I2 equal to 2.
2. Yeah.
So this is my first equation simplified. This also I can divide it by 5.
5.
Minus
Yes.
I1 plus 2 I2.
1.
So
Yes.
minus I1 plus 2 I2 equal to 1. So I have these two equations
Okay.
which I have to solve. So what I will do is I will keep my second equation as it is. My aim is to eliminate I2. Okay?
When we get that same I2, then we will cut that. And
Yes, that's why I will multiply this with 2. So 3
yes,
into 6 I1 minus 2 I2, 2 2s are 4, right? So this will get cancelled
yes,
out. 5 I1 is equal to 5. I1 is equal to 1. I got
1.
1
Yes,
I1. In any of the equation, I will apply this. 2 I2 is equal to 1. I will get 2 I2 is equal to 2. I2 is equal to 1. Okay?
yes.
This method we call it as elimination method. Because we are eliminating one
Yes.
variable to find the other variable.
By subtracting equation
Ma'am,
or
Vx is
by
0.
subtracting value.
Ma'am, Vx is 0.
Yes, right. Vx is nothing but IR. R is 5 ohm. I is I1 minus I2. Pi 1 minus 1 is equal to 0. What does that say? Here the current has been flowing in this direction. The current is flowing through this direction. Both are in opposite direction. So the currents are cancelling each other such that there is no current flowing in this circuit. Right?
Ma'am, I have a question.
Current
Like,
cancel out.
Yes. What about V? Why?
as you took I1 minus I2
Yes.
5-1.
Why I took
Ah,
I1 minus I2?
with the reference of current I1.
See, the 5 ohms is in between, right?
Okay.
Vy is equals to I into R. So our I is 0 because the current get cancelled out. Then I into R. Then
Ma'am,
0.
can we use KVL like up to a point in between the loop?
In between the loop, you want to use KVL. Like,
Like like for up
And
to a point.
Vx and Vy, does it
yes,
denote to voltage or current? Vx, Vy.
voltage. V is voltage, right? V is equal to IR. That by using Ohm's law. I is current, V is voltage, R is resistance.
Then Vy
Yeah,
is equal to 5 amps, V 5 volt. Vy. Answer,
Yeah,
in the
okay,
answer.
yeah. Sorry. So it's volts, right? Yes. Yeah, someone was telling something. Can you please repeat it again?
Then can we use KVL like up to a point in between the loop? Like in complete loop, we know that sum of all the potential is equal to 0.
Mm.
But if I want to go like for up to a point, not in the complete loop, then can we apply KVL?
You want to use from this point till this point, like that,
Yeah.
right?
Yes.
You can not like you can find the potential difference across this point, but you can't apply this rule because KVL says in a closed loop, potential increase is equal to potential decrease. If I say at this point, this value is V1, at this point also it is V1, then I can use because here and here the potential are same, so I will take it as a closed loop. But simply you can't use.
Ma'am, can you please one question for KCL?
Shall we solve the same question using KCL?
Okay.
It
Yes,
will be
ma'am.
easier. No?
Ah,
So again I will draw the circuit. 10 volts, 10 ohm, 5 ohm, 5 volt, 5 ohm. Yeah. My step 1 for KCL is okay. So KCL we are calling it as nodal analysis, right? Nodal analysis is nothing but KCL plus Ohm's law.
Okay.
So in KCL, what you are basically first you are doing is, first you have to find a reference node. I will take this one as a reference node. That I will make it as 0 volts. Okay.
Ground node. Yes.
Yes.
Ma'am, what is the meaning of reference node?
Yeah, I will come. Then we will identify all the nodes. Here, how many nodes are there? Only one. This V1, and there is 0.
V2. Yes, 0.
Yeah. So basically, what this reference node means, right? See, if there is a circuit like this, let me take a much more complicated circuit for. So if I see here, there is one node here. When do I call something as a node? When there are more than three branches, right? Then these are a one node. More than
More than 3
two
or
branch.
3?
More than 2 branch, I'll call it as a node. So here if I see V1, V2, V3. So basically there are totally 3 nodes here. Then I will make one node as 0 volts. So that with respect to this volt, I will find this V1.
Then if we draw like one more branch under this V3,
One more branch.
connected to V3,
Okay. From where do you want to connect?
like parallel to V3 under
Like
this.
this?
Yeah. And
Yeah, then your circuit will become, this will become one node V3. This will, okay, wait. What you're saying is, like this, right? So this will be my V3, this will be my V4. My number of nodes will increase. Then one node only I will make it as 0. Then I will find V1, V2, V3 with respect to V4. Okay.
Ma'am, it is
Now
compulsory to get
assume
But
one
ma'am-
as 0 volts. Yes. You will
to
understand
give
one
a
thing.
reference node.
You will understand why we are taking this as reference.
Yes, ma'am. To consider the voltage difference between 2 points and 2 nodes easily.
Yes. Find all the nodes and mark one as ground node. Okay. That is the first step of KCL. Then what does KCL say? At a node, sum of current entering will be equal to sum of current leaving, right?
Leaving. Yes.
Yeah. So first I will mark the direction of current. For my convenience, I am considering this is the current direction. I am assuming from V1 all the current is leaving. This you can assume either way. You can assume either it is leaving or it is entering also. Okay.
In the question
Can
itself,
we
the direction of the current is given. Am I right?
in the question, no, right? That is for your current. Yeah, it can either way. They can give or not give, no problem. But you can take either way because see, I am assuming I2 to be flowing from V1 to 0 volts, okay? But if in the question, if they are given the current is flowing in this direction as I, what is the relation between I and I2? I will be just equal to minus I2, right? Is it clear?
I is
Only the direction changes.
Yes.
Yeah. So
The step 1. What is the first word? Step 1.
ground node. Identify the like mark the ground node. Find all the
Ground.
nodes, then mark the ground node. Yes. Then the third step is okay. Here there is no current entering. So 0 is equal to I1 plus I2 plus I3. Now I will apply my Ohm's law. What does Ohm's law say? I is equal to V by R. V is the potential difference divided by resistance. My I1. This I1 is flowing from V1 to my tilt to the 0 volts. Okay. So I will consider everything. So V1 minus 10 minus 0 divided by R is 10 ohms. This is my I1. Do anyone have any doubt why I am writing I1 as V1 minus 10 by 10?
No, ma'am. We are taking that resistors.
V
Are
by
connected.
R. V by R. The
Yes,
path.
V by R.
V by R.
Since there is a voltage in my path, I am including that also. V1 minus 10
The
minus
last
0.
in the last zero refers to ground node.
Ground node. What I'm telling is I am taking this current path from point V1 till it goes to the 0 volt. Okay?
Not a complete circle.
Yes. Next, I2 is in this one. V1 minus 0 by 5 ohms plus this I3 path. Tell me the equation for I3. You guys try.
Like V1 plus 5 divided by 5.
Yes, it's plus 5 minus 0 divided by 5. Because see, if the current is entering, I will take it as minus. If the current is leaving, I will take it as plus. Okay?
Yes.
Now if you solve and tell me what is the value for V1.
Ma'am, 0.
Yes, it's 0. 5 V1 is equal to 0, V1 is equal to 0. So here it is 0 volts, here also 0 volts. So basically there will be no current flowing here, right?
Yes, ma'am.
Because they are maintained at the same potential. So this is how you find using KCL. Do anyone have any doubt in KCL and KVL? And all the problems
No.
which you solved today?
No, ma'am.
No.
Current direction. Could you please explain?
Current direction.
Which one is positive, which one is negative?
Okay. So this is V1. This I will take it as 10 volts. This I am taking it as 5 volts, right? So the current is flowing in this direction I1. This is flowing in this direction I2. This is flowing in this direction I3. This I will take it as Vx. So I1 plus I2 plus I3 equal to 0. So I'll write it here. I is equal to V by R. V is the potential difference, right? So at the starting point, so this is my 0 volts. It's Vx. So Vx. If you see this voltage source, the current is entering like this, entering the positive. So I'll take it as negative, minus 10. It's like
Because
at this
it's
point,
leaving from
Vx,
minus.
yes, it is leaving from minus. Yeah, you can take it like that also. It is leaving from minus, so you take it as minus 10. Then
Yes.
at the end, it is 0 volts. So minus
End-
0 divided by,
entering plus means minus.
yes,
Entering through plus minus. Am I right?
yes. For I3, you try the equation for I3, no? Is it minus 5 or plus 5?
Plus 5.
Yeah, it's plus 5. Is equal to 0. So in short, if the current is entering like, if it is X, then it will be Vx minus V1. Whereas if it is like this, it will be Vx plus V2.
Yes.
Okay.
This notation is used for KCL.
KCL. Yes. Yeah. Any other doubt? Do anyone have any other doubt?
Ma'am, could you please uh, move the screen a little up?
Yes. So the same question I'll move. So today we saw week 3 problems. Then we also saw one problem from KVL, KCL, mesh analysis and nodal analysis, right?
Yes, ma'am.
Yes.
Did
Yes,
anyone have
ma'am.
any doubt in any of the questions?
No, ma'am.
No doubts.
Really, it is useful.
Thank you, ma'am, for such a wonderful session.
Really.
Thank you, ma'am.
Ma'am, and we will discuss the graded assignment week 2 questions. Like in Monday we have class.
Okay. I will be taking the next Wednesday session.
Next Wednesday.
Yeah, because Monday another course instructor Shashwati ma'am will be taking. So I'll meet you on Wednesday. So you can ask to her also. Yeah, or else you can ask me also. No problem. You can feel free to ask anyone.
Okay.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Ma'am,
Yeah,
can you upload this one today or tomorrow?
Yeah, I will upload the slides
Slides. Today itself.
today itself. Yeah,
Okay, thank you.
in the portal, right?